In this video, I'll demonstrate how to perform a McNemar test, which is a nonparametric alternative to the dependent samples or paired samples t-test. But in this case, the outcome we're using is categorical. So typically it's what we call a 2x2 situation in which the outcome we're working with only has two levels. In the example we're going to be looking at someone having a diagnosis of a certain condition or attribute. They either have it or they don't, positive or negative. They'll go through an intervention, and then we'll reassess that person to see if they either no longer have that positive attribute or they've gained that positive attribute or whatever the case might be. So we've got one outcome here with two potential values, and we're going to be measuring the presence of that outcome in a pre-post situation. So it's a pre-test, post-test design, but the outcome we're working with is categorical. So it's essentially a 2x2 chi-square, but the assumption is being they're not independent, they are actually dependent upon one another. So in order to run the McNemar test, we're going to go to the analysis menu. We're going to find the nonparametric options, and then we're going to find McNemar's test. Now, the null hypothesis in this case would be that there would be an equal distribution of positive or negative results in the pretest compared to the post-test. So this is where we're going to have expected frequencies. So the null hypothesis would be the same distribution of positive or negative will happen in the pretest as will happen in the post-test. And then we're going to have observed frequencies, which the formula will then compare to those expected frequencies. And so it's looking for a pattern of difference in what's expected to what's observed. So the first thing we have to do is choose our variables, and we do like to choose them in order. So variable number 1 would be our diagnosis pre, and we click confirm. And then variable number 2, because there is a temporal order here, variable 2 would be our diagnosis post. And so that helps us kind of keep the context of what we're actually measuring and what we're trying to compare. We go ahead and click confirm, and then we click calculate, and then here's our result. So we'll go to the raw output here to assess this. And so what we're looking for here, here's the number of negative and positive diagnoses pre-intervention, and then here's the number of negative and positive diagnoses post-intervention. And so given what we are seeing in the pre-test, it's then being compared to the post-test. And so in order to determine if there is a significant change from the distribution of scores in the pre-test compared to the post-test, we're going to look at the chi-square result here. And we can see here that the chi-square value is 4.34, and that is less than 0.05. So there is a statistically significant change from the pre-test to post-test based upon the distribution of positive or negative on the diagnosis. Because this is a 2x2, we can determine an effect size by doing an odds ratio calculation using this 2x2 table. And so there are calculators out there that allow us to fairly easily determine an odds ratio calculation, and we can use that as an effect size. So we might be able to say that there is a 2-time greater difference of being positive for an attribute compared to negative from pre to post test, for example. And so that's another way to determine the magnitude of effect or the magnitude of change that might have occurred from the pre-test to the post-test. So hopefully you found this video useful, and good luck using it in your own